we've been working a lot with graphs. Whenever you do inequalities, you have to have a graph with it because it's not just one solution that works for an inequality. So just like with the system, for inequalities, we had to find a whole group, a whole area that was the solution for our system of inequalities. But now, kind of switching gears a little bit, we're going to do a system of equations instead. And since it's an equation and not an inequality, we really don't have to look at the graph because what we need to do is really just find the one ordered pair, the one x and y that's in common with both of your equations. So you can look at the graph. There is a graphing part to it, but I tend to focus on the more algebraic part so that you can just find it by just doing some calculations, okay? So that's what we're going to work on today. So a system of equations, much like a system of inequalities, is you just have to have two or more equations. And so the systems we're going to work with today, we'll just have two. And then what we're trying to find is the ordered pair or the x and y that are in common with both of the equations that we're given. So like I said, essentially if we were to look at the graph, it would be where they intersect. So that intersecting point that we weren't necessarily worried about with inequalities. That's the point we're finding. Like I said, you can do that by graphing it, or you can just do that by working out some math by hand. So we're going to go through those steps here in a second. Before we do that, there is some kind of things you need to know about the system. So for the most part, and the ones that give you will, for the most part, have that one solution where you find the common x and y for the two equations that you're given. Every once in a while, you get some kind of unique lines. Because essentially what we have to do is take your two equations and put them together somehow, and then we'll work out one value, and then once you have one value, you can find a second one. But every once in a while, if you put them together, something kind of weird happens. And so there is a possibility for when you're working with the system to get a no solution. That happens when you have two parallel lines. You won't necessarily know that they're parallel just by looking at them, but if you take your two equations and put them together, and what essentially happens is all your variables are going to go in. So the 0x is 0y, so you'll just be left with some numbers. When that happens, then you know those two lines are parallel, and then there are no solutions. Okay? So if you have two lines that are parallel, they're never going to intersect. And so since we're just working with equations, they can't have a solution because we're just looking for one point where they intersect, and if they don't intersect, there is no solutions. So that's kind of how that situation works out. Is if you put your two equations together and all the variables go away, they're all 0, and then you're left with a statement like 6 equals 5 or 2 equals 7, something that's not true, then you know it's a no solution. Now, there's one other alternative to that, and it actually works the same way. It is possible for you to have an infinite number of solutions, and when that happens, that actually means that you are working with the same line. Okay, so you have two different equations, but they essentially just make the same line. So what happens then is that every single point on both lines are going to line up because they're kind of right on top of each other. So that means you have an infinite number of solutions. And so that actually works the same as, or it's similar as when you get no solution. So when you put the two equations together, again, all the variables are going to go away. So you're going to have 0y, 0x's. But then what you're left with is something that actually does make sense. So like 6 equals 6 or 0 equals 0. Something that is actually true. So if that happens, then we say there's an infinitely many solutions. So the phrasing we use for infinite number of solutions is infinitely many. Sorry, spelling's hard. And we don't see that happen often, but every once in a while, like I said, you'll go through all the steps perfectly to find the solution, but something happens weird with your variables, and so then if you're left with a true statement So something that actually equals one another. Sometimes it's 0 equals 0. Sometimes it's 6 equals 6. Again, something that makes sense. Something that's actually true. It's infinitely many. And then if you go through again, same process, go through all the steps correctly, but the variables go away, and you're left with something that doesn't make sense. So like 6 equals 10 or 2 equals 5. Then it's no solution. Okay? There are actually two methods that we're going to learn. We're just going to focus on one of them today. We're going to do the substitution part. So both methods, essentially, it has the same idea. Taking the two equations, meshing them together for a little bit to find one of the values. And then once you find one value, so either x or y, then you can use that to find the other one. Okay? So let's go through our steps. Orange is very good for the video. Okay, so like I said, you're going to be given two equations. They can be in any way. You can have some that are already in slope-intercept form. You have some that are in standard form like they are now. But again, you're going to be given two equations with x's and y's. And then what we're going to do, like I said, is take them, put them together somehow. When you do that, one of the variables will go away for a little bit. So then you'll have just one variable to solve for. And then once you have that one variable, then you can go back and find the other one. So essentially, like I said, we're going to get essentially two answers. We're going to find the x in common and the y in common. And then we're going to write our answer as an ordered pair. The first step is to look at one of my equations. You don't have to do this for both of them. And what we want to do is solve one of the equations for either x or y. Okay, it doesn't matter which one. When we were graphing, we were picky. We said we had to solve it for y, but if it's easy to solve for x, you can do that as well. But we have to get one of the equations, not both, and it doesn't matter if it's the top equation or the bottom equation. You have to get one of the equations where one of the variables is by itself. So typically what I look for is something that's by itself kind of already. It's like on this top equation, see this x is pretty by itself. The only thing that's rounded is the y, so I can move the y over and I can get x by itself. Also on the flip side of that, y is also pretty much by itself. I just need to move the x away from it. So with this system, there's actually a couple of options you can do. So that top equation.
I'm having trouble hearing you.
Thanks, sweetie. Sorry. That never works when I actually want it to work, and then it works like right in the middle of this. Okay. Sorry. So whenever you have something like this, it's your choice. You get a choice. You can solve it for x, so you just need to move the y over here, or you can solve it for y, move the x over to 3. So what do you want to choose? Do you want to solve for x or y? X. Okay. So again, I'm not worried about this bottom equation just yet. So I'm going to take this top equation and I'm going to solve it for x, so that x is by itself. So I have x equals negative y plus 3. So that's my first step. Take one of the equations and solve it for one variable. So you get one variable by itself. So like I said, with that top equation, you could have done it for either x or y. So x is pretty easy to do. So that's our first step. The second step is once you have one of the equations, again, it doesn't have to be the top equation, it could be the bottom equation. Once you have this solved for a variable, so that x is by itself over here, you're going to take the expression that it equals, so the thing with y, and you're going to substitute it into the other equation. So like I said, what we're doing is essentially taking our two equations and putting them together. So since this is what x equals, we can take this expression and substitute it in for the other x and the other equation. I'm going to write that substitution below step 2. Okay, so we're going to completely replace that second x in that second equation with that negative y plus 3. Okay, so like I said, essentially when this happens, you're going to get rid of one of the variables because we've replaced this x for this expression with y from our first equation. Now we have to keep all the rest of the equation with it. So behind that, I'm going to put plus 4y and then equals 6. substitution. So you notice x is gone from that second equation. We've replaced it with that negative y plus 3. And then we still have to have the rest of the equation, the plus 4 and this equals 6. So we've taken the two equations and meshed them together. So when you do that, again, we should notice there's only one variable left, and when you have one variable, you can solve for it. And so that's what the next step is. We're actually going to take that and solve it for y. Now yours is all on the same page. I have to flip my page, so give me 1 second to get where you are. So let me just rewrite it over here real quick. So solve for y, what do we need to do first? Yep, we're going to distribute. Make sure you distribute that 2 with it, or that negative with it. So we got negative 2 times the negative y is going to be a positive 2y. Negative 2 times 3 is a negative 6. And then again, we still have the rest of the equation, plus 4y equals 6. On the left-hand side, we have a couple y's. So the next thing I'm going to do is combine those. Again, we're not moving it across the equal signs. We're just going to total up how many y's we have. So we don't need to worry about moving the y's together. We just need to combine it and make it 6y. Since they're both on the same side of the equal sign, so we can just add them together. So we have 6y minus 6 equals 6. That's a lot of 6's. So now that we have it distributed, combine like terms, now we're just back to a regular equation to solve. So what's our next step?
Add the 6.
Yep, move the 6, add the 6. So we have 6y. Add 6. 6y equals 12. So then what do I need to do?
Divide the 6.
Divide the 6. So y equals 2. So I don't know what my y is in common. Any questions about how I did that? So essentially what it is, it takes a little bit of work to find one value. Okay, but like I said, there's actually two parts to our solution. We have y. We also need to find the x that's in common. So the last step is to take that value, let's go back real quick, and you can substitute it into one of the equations that we have. So either of the two originals would work, or you can even use the one that you've rearranged. So now that we know what y is, we can just take it, we can plug it in here, solve for x. We can plug it in here, and then we just find what x is. We can even put it down in here. So you can put it into any one of the original equations. Now that we know that y was 2, we can put it in any one of those places. Which one do you want to use?
A rearranged one.
Yeah, the rearranged one. So that's typically what I use, because all I have to do is put negative 2 or 2 right there. That'll make it negative 2 plus 3, so x is going to be 1. You don't have to rewrite this every single time, but since mine's on a different page, I rewrote it. So I use that rearranged equation. I put my y value that I found in step 3 into the y in that. And so now I just need to do a quick addition. And so my x value is 1. Now, I am going to be a little picky about how much final answer. So I have my x, I have my y. I want you to write it as an ordered pair. Okay? So my x comes first. So my x is 1. My y is 2. So then my final answer is going to go as an ordered pair. And I'm going to circle that. Questions about that? So it took a little bit to find the first one. Again, we had to rearrange one of the equations. And we had to put the two equations together so that we could find our first value. Then once you found the first value, plug it into the second one, or plug it into one of them to find the second value that we need. So now I just have a few more examples. We may not go through all of them, but like I said, we still have that extra possibility of the no solution or infinite solutions that still show up. Essentially, when you're going to know if it's one of those is when you get to this part of the process. So here I can combine my y's. Usually when that happens is when you combine your y's, you get 0 for your y or 0 for your x. Then I know it's either going to be a no solution or infinite. So usually when those extra possibilities happen, it's right here in that step 3. So let's look at the next one. Sometimes the first step is already done for you, okay? If you look at that second one, what do you notice about that equation?
That is by itself.
X is already by itself, okay? So I don't have to worry about rearranging anything this time because that second equation already has X by itself. So I can take its expression, this 2y plus 6, and I can go ahead and plug it into that top equation, okay? So sometimes you don't have to do that first step because one of the equations is already has one of the variables by itself. Okay. A couple things about this one. When you notice as we go through this one, I kind of combined some stuff with this. So first of all, I already showed you we could already have step 1 done. When you substitute something in with a negative, do make sure that's like a negative 1 out in front of it. So you are going to have to distribute that. So if you want to, you can change that to a negative 1. You don't necessarily have to write the 1, but like I said, make sure you're really careful with your negatives with this, because if you miss a negative when you're substituting, I can throw your whole answer off. So again, I replace the 2y plus 6 with the x in the top equation. Again, keep that negative because we're going to distribute that here in a second. And then also don't forget the rest of the equation. So then I also have the 2y and the negative 12. So then what do I need to do? Distribute. Yep. So I'm going to distribute that negative. So I got negative 2y minus 6 plus 2y equals negative 12. Okay. What's going to happen here?
It's gonna be 0.
It's going to be 0. Because if I combine my like terms like I did on the last one, negative 2y plus 2y is 0y. So essentially you can get rid of those. And so this is going to be either a no solution or an infinitely many solution. So if, like I said, usually in that step 3 when you're solving for the variable that you have left, that's when you're going to figure out if you have one of those extra possibilities. So then what you have to look at is this, what I have left, is it true or false? If it's true, then it's infinitely many solution system. If it's false, it's a no solution. So if I look at what I have, is negative 6 equal to negative 12? No. So then this would be no solution. And you don't have to say this, but what that means is if I were to look at the graphs of these two equations, they would be parallel. So it never intersect. And like I said, you can't necessarily tell right away that they're going to be parallel, because if you look at them, the two totally different types of equations, but they would have the same slope if we were to graph them. Okay. Questions about that? Okay, let's do the next one. For sure. So this one, you don't necessarily notice a variable that's kind of by itself already. Like with our first example, there's the x or y would be pretty easy to solve for. With this one, there's numbers in front of all of them. So what I look for is something that's easy to divide. So actually, you can have a couple of different options with either one of these. The one that sticks out to me is this bottom equation. I have some 3's and 18's. Okay, so I know all of those are nicely divisible by each other. So that's really what I'm going to pick. Is you can do either x or y. I'll probably do y this time since we've done a lot with x's. But that's what I notice is if you look at the equation, if there's numbers that are nicely divisible by each other, then you can rearrange that to get a variable by itself. We can do that with the top one because these are nicely divisible, but you have to be careful with that because if you solve for y, you're going to end up working with a fraction because if you take 4 divided by 8, it'll be 1/2, which is not a bad fraction to work with. So that's why I would stick with maybe solving this bottom one. And I'm going to go ahead and choose for us. I'm going to solve for y since we've been solving for x for the last couple of years. So I'm going to move the 3x over onto this side. So I got 3y is equal to negative 3x plus 18. Then I have to divide the 3, and divide 3 everywhere. So that y is equal to negative, you can put a 1, I'm just going to put an x, and then plus 6. So most of the time, it's really not a ton of thinking to do with rearranging it, but if you do have numbers in front of every variable that you have, you kind of think about it a little bit, because if you rearrange it, you can work with fractions or decimals, that's fine, but I usually try to pick it so I work with whole numbers. So now what do I need to do?
Plug in the other one.
Yep, we're going to take that expression I got for y, we're going to plug it in to that top y. So we're going to replace all the y's in this equation, so we should just have x's left. We can do that down here. So I have 4x, and it's minus 8 times, now this whole expression, so that negative x plus 6, and that equals 0. Now what should I do? Yep, distribute. Again, always make sure watch your signs. So 8 is negative, so make sure you distribute that negative along with it. So we got 4x, that's going to become a positive 8x. Excuse me, negative 48, and equals 0. Now what can I do? Add my like terms, yep. So again, they're on the same side, so I just total up how much I have. Excuse me. I just have a cold. So the next, we have to get x by itself. So I'm going to add 48 over here. So I have 12x is equal to 48 divided by 12. So x is going to equal so like I said, once you've got this distributed, combine like terms, then once you get here, it's just a regular equation. So I add the 48, divided by 12. Now what do I need to do?
Put them in an order pair.
Yep. So I have x, what am I missing? Y. So I need to find y real quick. And again, you can use any one of those equations. I'm going to pick this middle one that I solved. So I'm just going to throw my x in here. So that'll be negative 4 plus 6. So what's y going to equal?
2.
2. So now I have my x and y. I'm going to put it in an order pair. So x comes first, so it's 4. I'm going to 2. Good question. I have another example if we need to go through it. You think we're okay? So, like I said, substitution, it's just all crunching numbers. So you rearrange the equation so you can get the two equations meshed together, then find one value. Once you find one value, use the other equations to find the other one.